All right, so first let me create a C++ file. And that's good enough right there. And let me include IOStream. Let me see here. It looks like I am going to need the string library as well. Using namespace int main system pause return 0. Save my work. All right. So the first thing that I'm going to do is to ask the user, for a character and then for a number, and then I'll convert from character to ASCII and then from ASCII to character. So I need some declarations. First, my car, which is just a character. And I'm also going to need my character converted. I'll have ASCII value. And then I'll have ASCII value converted. We'll get the user input. Cout. Enter an ASCII value. So I'll need to obtain that from the user, and we'll put that into ASCII value. I'll also ask the user to enter a character value. And I will obtain that and put that into my character, which is a variable that I created above. Now, to convert, put that in the calculation section. So we'll say my character converted. We're going to assign that. We've talked about casting before, how to cast a double as an integer or an integer as a double. So let me talk to you about static cast. Static cast is a great tool that allows you to convert temporarily or to treat temporarily as something else. So in this case, what I'm going to do is I'm going to take the ASCII character that I obtained, and I'm going to cast that temporarily as another value. Sorry about that. Static cast as a character. And then ASCII character. So let me stop right here. If you go to a different country, and some countries have the caste system, which means that people are ranked. So you have the royalty, that's the highest caste, and then you have, maybe the worker, and then you have the plebe at the very bottom, right? So that's exactly what this is talking about. This caste system means to treat as something different. So what are we going to do with this number over here? Do you see how this is an integer? I'm hovering on top of it, and you can see right below here, this is an integer. But how am I going to cast it as? I'm going to cast it as a character. And I intend on putting it here into my character converted, which in fact is a character. Yes?
Would the character that was converted return to an integer?
No. I'm sorry. Would it return? It never changed. It never changed. It still is what it is. Temporarily. For this particular variable. That's exactly right. Yeah. So it never changes. You're just temporarily casting it. So over here for the ASCII character converted, again, we'll use static cast. And I want to temporarily treat this as an integer. Now, What is it that I'm going to temporarily treat as an integer? That character that we obtained, my character. So what does this do? This right here, as you can see below, is a character. We are going to treat it as an integer temporarily so that we can assign it into an integer. And then finally we have the output section. So we'll say something like this, cout.
I have a question.
Yeah.
When we're entering your ASCII value or your character value, are we entering characters or are we entering numbers?
Well, over here, when it says enter an ASCII value, that will be a number. For example, let's say that the user entered 97. Well, the character equivalent of 97, as you can see here, is the letter A. And that's what we want to show. We're going to enter 97, and we're going to display, hey, 97 is the same thing as A. Or if the user enters a character, such as the letter A, we're going to convert that, and then we're going to see that the ASCII value of the letter A is 97. So we're going both ways. All right, so we'll say something like this. Cout, we'll say the character equivalent of ASCII, and then I better send out whatever that ASCII value is. Well, it looks like we called it what? ASCII value. So ASCII value is, and then we converted that. We took that and we converted it, and it's this guy over here, my character converted. And then we'll go to the beginning of the next line, endel. So you entered 97. We should see the letter A over here. The character equivalent of ASCII 97 is A, is what will be displayed when we run this. Cout, the ASCII equivalent of character, and then I want to enter the character that was entered, which is my car, is, and when we took that and converted it, it looks like we say ASCII value converted. And we'll go to the beginning of the next line. Yes, question?
So does the computer actually understand like the ASCII system?
It doesn't understand it. It's been inserted such that this function will look at a lookup table and convert from one to the other.
Okay, because when you put in like the static cast, char, ASCII value, is it like converting it to a number? It becomes a number because that's a character.
It will take a number and convert it into a character, or it will take a character and convert it into a number.
Okay, so it looks up the table and actually does it. Okay, now.
So if I run the program and let's make that a smaller font, 18 is fine. Enter an ASCII value, 97. Enter a character, A. All right. The character equivalent of ASCII 97 is A. The ASCII equivalent of character A is 97. And that is in fact true because if I go back over here, what is A? 97. What is 97 converted to a character? A. Let's try something else just to see if this works. And by the way, I should have put capital letter T here. Run the program. All right. Hold on for a second here. Let's try Z, for example. So, and Z is 122. And the character is this. So the character equivalent of ASCII 122 is Z. The ASCII equivalent of character Z is 122. Perfect. Yes.
Okay, my question is now is this only specifically set up for ASCII conversion, or because I'm just thinking we've done other programs here where we've had to convert to strings and stuff. Now, does this type of format obviously eliminates it? No?
No, this is what is used specifically for converting from a character to an integer, from an integer to a character. I can convert from an integer to a double, or from a double to an integer. It's not, I really shouldn't have said the word convert. It's casting, it's treating temporarily as. So this really is represented in a different way. This is being represented as a character, whereas this guy over here is being represented as an integer. So it can go above and beyond just ASCII character. Yeah.
So how would that work if like you have a string? You know what I mean?
Give me an
Converting a string to
example.
an integer or something?
Give me an example. How do you convert a string to an integer?
The thing is, I don't know. I'm just trying to.
Oh, you're asking, can you convert a string to an integer? Answer, no. No.
Yeah, that's what I was.
So I type in ONE. How does the computer convert that to the number 1? It doesn't. I have to actually create a program to say ONE is really the same thing as the number 1. So there is no string to integer conversion. Now, is there like a number to string conversion? Yeah, we've used that before, right? We've used toString. And what toString will do is it'll take a number, that's right, it'll take a number and treat it as text, if you want to. You want to come on in? You want to come on in? He's probably looking at the stuff over here. Doesn't? You want to come on in?
No.
Oh.
This is the room.
Yeah, there's a bucket right here, and it's bulging right there.
Okay, we want to identify.
All right, sounds good. No problem. Yeah, that's a good project right there. You go to a bank. The bank has hired you to write a check writing program. They want to enter 1, 2, 3, so you have to generate the text 123, all those letters, because they type in 1, 2, 3. Right? So you couldn't use static cast as a way of converting 1, 2, 3 to the words or to the letters ONE space TWEN, so forth and so on. Right? Yeah. You would have to generate a program to do that.